Your skin holds secrets. Tucked away at the base of every hair follicle is a small population of stem cells, not the ones that build the hair itself, but a different group responsible for the oil-producing glands. For years, their potential was thought to be limited to that single greasy task. But in a lab studying wound healing, a strange thing happened. When the outer layer of skin was damaged, these specific stem cells, known as LGR6 cells, didn't just sit there. They migrated, they transformed, and they began to build entirely new skin, a function nobody expected them to have. The trigger for this incredible career change was a molecule you've known about your whole life. This molecule, retinoic acid, the active form of vitamin A, acts less like a building block and more like an architect's blueprint, revealed only in an emergency. When your skin is cut or even just scraped, the local concentration of retinoic acid skyrockets. It's a chemical flare signal, a command broadcast to the surrounding cellular neighborhood. This sudden flood of information doesn't just call for reinforcements. It fundamentally changes the nature of the cells that hear it. It's an instruction to forget what you were and prepare to become what is needed. What does it mean for a cell to forget? A mature skin cell is highly specialized. Its genetic expression is tightly controlled to perform one job. Retinoic acid pries open that genetic lockbox. It triggers a cascade of gene activity that essentially silences the skin cell identity. This process, called de-differentiation, is a form of cellular amnesia. The cell loses its specialized features, becoming more like an embryonic or stem cell. It is now a blank slate, ready to receive new instructions and build whatever tissue is required to seal the breach, not as a simple patch, but as a seamless, integrated reconstruction. This regenerative power isn't confined to your outer surface. Think about the lining of your intestines, a barrier just one cell thick that faces a constant chemical and mechanical assault. It completely replaces itself every few days. This incredible feat of constant self-construction is heavily dependent on the same vitamin A pathways. Here, retinoic acid orchestrates the continuous maturation of stem cells to replace the millions of cells shed daily. It ensures the barrier between you and the outside world, even the world inside your gut, remains intact. The same principle applies to the delicate linings of your lungs and other internal surfaces. But how does this connect to vitamin A's most famous job, sight? It turns out vision isn't a passive process. It's an act of perpetual molecular-level regeneration. Inside your retina, a molecule called retinol waits. When a single photon of light strikes it, the molecule physically changes its shape. This shape shift is the spark that your brain interprets as light. But now that molecule is spent. It can't detect another photon. An entire enzymatic machinery called the retinoid cycle exists for one purpose: to grab that spent molecule, rebuild it to its original shape, and put it back. Every single moment you are seeing, you are actively rebuilding the chemical basis of your own perception. It was never just about vision. It was always about renewal.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.